Okay, so I want to take a look at some more examples, and I realized on my on my very last video that I did make a mistake, and I sent out a remind on that. But when we were doing the oblique asymptotes on number 4D, I did have an error, and so as I'm taking a look at here, just so so I can sleep tonight. For some reason, I accidentally made this a negative 12 instead of a positive. So let's just reiterate this one more time, just so we have the right answer. Go ahead and erase that. I'll try to, I should say. Maybe. There we go. Last of that. Should erase. There we go. Okay, so just real quick, just again, so I can sleep tonight. You do your long division. So 2x squared plus 4x minus 1 divide into 6x cubed minus 6x squared plus 4x plus 7. So we said before, it's like a 3x. 3x times 2x squared is 6x cubed. 3 times 4 is positive 12x, not negative, and then minus 3x. So when you subtract, we get that 0, but now we get a negative 18x because it's negative 6 minus 12, and 4 minus a negative 3 is plus 7x. Bring down your 7. And so then now we get negative 9. So negative 9 times 2 is negative 18x squared. Forgot my squareds there. Negative 9 times 4 is negative 36x. Negative 9 times negative 1 is positive 9. So we subtract once more, and our 18s cancel, negative 18s. 7 minus negative 36 is positive 43x, and then 7 minus 9 is negative 2. And so again, this is the remainder, but the actual equation of the oblique asymptote is 3x minus 9. So my equation, y equals 3x minus 9, is the correct answer for the oblique asymptote. I apologize for that. Now, there was one more example up here that we haven't done yet, which was example B. And so for example B, it says, graph this. And so it's our first one where we actually have a horizontal asymptote at y equals 1. And so I know that the bottom factors as well. So like x plus 6 times x minus 1. So x plus 6 times x minus 1, and we have this x squared. So I also know there's two vertical asymptotes. These don't cancel. So I have a vertical asymptote at x equals negative 6 and a vertical asymptote at positive 1. So my horizontal asymptote is y equals 1. My vertical asymptote is x equals negative 6 and x equals positive 1. If I let x be 0, I get 0 as my output. So that's both the x and the y intercept. X/y intercept. That's always nice when it's like a twofer, right? So it's both 0, 0. Okay. So then let's go ahead and start sketching some things on our graph here. And there's one thing that we need to check in a second. So here's our y-axis. Here's our x-axis. And so then I know there's a vertical asymptote at 1. Right, so x equals 1. I know that there's a vertical asymptote at negative 6. And then I know there's a horizontal asymptote at y equals 1. Okay, so, and then I also know it goes through 0, 0. Now, we can't really tell by looking at the numerator, like we did in the previous one, like when that was 0, it was easy to see across the horizontal asymptote because the horizontal asymptote was 0. But in general, there's a question that says, like, how do you know if your graph crosses, I can talk, the horizontal asymptote? So here's how you check. You have to set function equal to the asymptote and solve. Equal to the asymptote and solve. And we're going to find out for the oblique one, that's going to be the same thing. So if I set my equation that we knew there was a horizontal asymptote at y equals 1. So if you set this entire equation equal to 1 and solve, we can algebraically determine if it crosses some point. So 1 equals x squared over, I'm going to leave it expanded. Now, normally when we would have multiplied this quantity over, we'd have gotten a 0, but that's because the horizontal asymptote was 0. Here it's 1. So when I multiply, I get x squared plus 5x minus 6 equals x squared. And now I can subtract the x squared, so I know they cancel. So I get 5x minus 6 equals 0, which means that 5x is equal to 6, or x is 6/5. So there's my cross point. The x value is 6/5, and you might be wondering, what's the y value? Well, since it's crossing the horizontal asymptote, then you know that y value is going to be 6/5 comma 1. So we're finding that point right there. That point right there is 6/5 comma 1. Now, finding that cross point actually is a really good thing, because if we think about the nature, like what's happening to the right of 1. So if I highlight this region over here, right? This region all over here, and I realize that I have to behave like that, the asymptotes. Remember, there could be one of two things. Like I'm either going to be bounded above or bounded below. So like, either like something like this or something like this, but we know it can't be the one that's below, because that would, I have to go through this point, which would require me to cross the x-axis right there. And remember, there's only one x-intercept. The only time this equals 0 is at 0. So I know I can't possibly cross there. So it's not that option. So we erase that, and the only possible option is this upper branch. And the thing is that we must dip below here, but then we kind of just hug that asymptote above, and we do something like that. I know it can't cross, again, because again, the only time we had the intercept was at 0. And so I'm forced to have that. Now, next, think about the next region here. I'll go ahead and highlight that in green. So this region here, well, my highlighter is kind of like acting kind of screwy here today. This region here, think about the behavior and use the multiplicity, right? X equals 1 came from a multiplicity of a factor of, this factor had multiplicity of 1. It was odd, right? So I know that because that was an odd multiplicity, a 1, we have to change signs. So if I'm on the upper part of the asymptote here, I'm going to be in the lower part down here. And I know I had to just hit this point, and I can't cross this asymptote anymore because it only crosses once. And I know that the multiplicity of that factor is squared, so it's even, so it's going to just bounce right back on down. So I know it's going to do something like this, because it has to touch that point and come back down. So we have this part of the graph. We're staying above, and then we switch signs. So now we're touching and going back down. There's no other times it touches because there's only one x-intercept, and it's an even multiplicity, so it's a bounce. And then looking at -6, its exponent is also 1, so it's odd. So if I was down here, I'm going to be up here. And again, we know that it has to be like that because we don't cross the x-axis anymore. We don't cross the y-axis, or sorry, the line y equals 1 anymore. So it's a little bit trickier initially, perhaps, because we got to check that cross point, but it's so important. It's so important to know, how do you check that cross point? You check it by setting the asymptote equal to the equation, and then you solve. Okay. Now, I wanted to fix my typo on that one problem, and then obviously go through this next example of horizontal asymptotes. So the final couple videos then will go through some more notes on graphing problems that also have oblique asymptotes and potentially some holes.